technologies for core engineering application. Very, very important area. So I'm extremely thankful to our Vice Chairman, Honorable Vice Chairman Sri Utkarsh Gautam ji, Principal BCET, and Chairman Institute of Engineers India, Dr. Bimal Das, Dr. S.K. Srivastava, Chief Guest of today's program, Dr. Nirmal Kumar Rai, the keynote speaker, as well as I'm extremely thankful to the organizers. That is, I must talk about HOD Mechanical Engineering, Mr. Mintu Ghosh, Dr. Gopal Chandra Das, Dr. B.P. Roy, HOD Electrical and Communication Engineering, and Dr. Dinesh Day, HOD Chemistry, for organizing this program. I'm also thankful to all the resource persons, all from IIT United. So, Dr. Arya Jyoti Goswami from NIT Dugapur, Dr. Ditya Das from NIT Dugapur, Dr. Ravikant Jain from CNERI, Dr. Tushar Kanti Bera from NIT Dugapur, Dr. S. Banerjee from NIT Dugapur, Dr. Vivekananda Sharma from Institute of Porous Materials, Paris, Dr. Hemant Kumar Mandal, NIT Dugapur, Dr. Sudhir Kumar, Associate Professor IIT Patna, he is our student. Sudhir Kumar is our student, and Dr. Subhash Chandra Saha from Australia. So all these resource persons are joining in the program. I'm extremely thankful for them, and all the participants. I'm extremely thankful. I think this 5 days program will be extremely unique. Let me tell you, this year we have organized international seminar of AI impact that is held in New Delhi, where more than 110 countries participated. Heads of the state participated. So AI becomes very important. So application of AI in core branches of engineering becomes very, very significant. Under this backdrop, this particular program, 5 days program, assumes tremendous amount of significance. With these few words, I welcome you all and wish the program a very grand success. Thank you.
Thank you very much, sir, for your inspiring and motivating words. Now I acknowledge the continuous support and guidance of the Chairman of Institute of Engineers, Dr. Bimal Das, in organizing this event in a successful way. And now I request Dr. Das to address the virtual gathering. So, sir, please, it is over to you.
So good morning. Is it audible to you?
Yes, sir. Good morning, sir.
Good
Yes,
morning
yes.
to all the distinguished dignitaries, respected academician, industry experts, faculty members, and dear participants. It gives me immense pleasure to welcome all of you to this 5-day short-term training program, as well as this faculty development program, jointly organized by core engineering departments and basic science departments of Bengal Engineering College, Durgapur, in collaboration with this Institution of Engineers, India Durgapur Local Center. At the outset, I extend my gratitude and warm welcome to our respected Chief Patron, Sri Utkarsh Gautam, Vice Chairman of SKS Industry Groups, whose encouragements and supports make such academic initiative possible. I also warmly welcome our esteemed chief guest of today's event, Sri S.K. Srivastava, former Principal Director of National Power Training Institute under the Ministry of Power, Government of India. His vast experience and leadership in the power sector will surely inspire all of us. My special greetings to our all the distinguished keynote speaker from NIT Durgapur and also in CMRI. okay, to their valuable uh, insights. Okay, it will basically enlighten our students, our researcher, all our participants. Now, 1 minute, so we want to say about the Institution of Engineers. This Institution of Engineers established in 1920 and its headquarters in Kolkata is one of the largest professionals in engineering bodies in the world dedicated to promoting engineering excellence, professionals development and technological advancements. And the Durgapur local center has been actively contributing to this mission by organizing technical lectures, workshop, training programs, and collaborative academic industry initiatives for this benefit of engineers, researchers, and the students in this our region. So I request all of you uh, use these benefits of Institute of Engineers. Now, I also extend my warm welcome to our to the director of SKS, this industry groups, the principal of Bengal Engineering College, respected members, and all the participants who have joined this program. And we know that this objective of this FDP or this short-term program is to provide a platform for knowledge sharing, academic interactions, and technological exchange among educators, researchers, and professionals. So, in today's rapid evolving technology landscape, continuous learning and professional development are very much essential to keep space in emerging innovation. I am very much confident that over this next 5 days, this program will provide valuable insights, encourage meaningful discussion, and enhance the academic and research capabilities of all participants. Once again, I welcome all the distinguished guest participants to this program and wish this FDP great success. Thank you.
Thank you very much, sir, for your motivating and insightful word. Now, I request my co-host, HOD English, Supriya Sahabanik ma'am, to continue the session. So, ma'am, please, it is over to you.
Good morning, everyone. Am I audible?
Yes, you are audible.
Okay. So, thank you, sir, for handing me over the session. I, Supriya Shahabunik, HOD Department of English, BCET, would like to continue with the session. So, on this auspicious day, I find myself blessed to announce that we are having among us So, the thank chief you, guest, sir, for Dr. handing S. me K. over the Srivastav, session. former I, principal, director, National Power Training Institute, Ministry of Power, Government of India. Sri S.K. Srivastav is a distinguished electrical engineering graduate with a Master of Business Administration MBA and completed a project management course from Indian Institute of Management, IIM Lucknow. He is a seasoned professional with more than 33 years of extensive experience in the field of training and development in the power sector. He recently superannuated from the position of Principal Director at National Power Training Institute NPTI under the administrative control of the Ministry of Power, Government of India. Sri Srivastav was also honored with the prestigious Best Director Award of NPTI 2024 for his exceptional administrative acumen, commitment to quality training, and transformational leadership. His professional journey stands as a testament to his unwavering dedication, technical excellence, and visionary leadership in advanced training, innovation, and strategic development in India's power sector. I would gladly take this opportunity on behalf of BCT to request our chief guest, Dr. S. K. Srivastav, sir, to enlighten us with his words of wisdom. It will be a pleasure to listen to his words of wisdom. I hand over the session to our chief guest, Dr. S. K. Srivastav. Sir, please. Sir, are
Thank,
you can you hear me? Yes, sir. Sir, please continue with the session.
May I audible?
Yes, sir. Good morning, sir.
Am I audible?
Yes, sir, you are audible.
Good morning. So, good morning.
Good morning, sir.
Good morning to all. So, respected Professor Dr. S.E. Ganguly, the Director Administration, BCET, Sri Bimal Das, the Chairman, Institution of Engineers, Durgapur Local Chapter, and all other respected dignitaries, faculty members, researchers, resource persons, and my dear participating friends. At the outset, let me thanks to the organizer for inviting me to this inaugural program on the theme Recent Advances in Intelligent Systems and Smart Technology for Core Engineering Applications. We are living in a time where technology is evolving very rapidly and intelligent systems are changing the way engineering solutions are designed, built, and managed. Today, technologies like artificial intelligence, machine learning, the Internet of Things, and advanced data analytics are helping engineering systems become smarter, more efficient, and more responsive. These technologies allows machines and infrastructure to sense their surroundings, analyze large amount of data, and make better decision with minimal human intervention. One very exciting development in the recent years is the concept of digital twins. You all might be knowing that. These are virtual models for a real world system that allows engineers to simulate, monitor, and improve physical processes in real time. Digital twins are now being widely used in manufacturing, construction, transportation, and energy sector to improve efficiency, reliability, and safety. At the same time, the combination of intelligent systems with Industry 4.0 technologies has transformed the modern industries. It has made things like predictive maintenance, automated quality control, and smarter production planning possible. These advancements help industries reduce downtime, improve productivity, and move towards more sustainable practices. Another important factor supporting this transformation is the development of modern communication technologies such as 5G, which provides fast and reliable connectivity for a huge number of smart devices. This connectivity is essential for building smart cities, autonomous systems, and intelligent transportation networks. However, while technology is advancing quickly, the role of engineers has become even more important. Engineers must not only design intelligent systems but also ensure that these technologies are safe, ethical, secure, and beneficial for the society. Innovation should always go hand in hand with responsibility and sustainability. If I speak briefly about the power sector, right now, electricity demand in our country is growing quite rapidly, roughly about 9% per year. To meet this rising demand, The country has already built a large power system with a total installed capacity of around 520 gigawatt, that is 5,20,000 megawatt. A significant point is that more than 50% of this capacity now comes from the non fossil fuel sources such as solar, wind, hydro, and nuclear, showing a clear shift towards the cleaner energy. At present, the peak electricity demand is around 250 gigawatt, and it is expected to touch about 277 gigawatt during the upcoming summer season when cooling needs increase across the country. This steady rise in demand means the power sector has to continuously strengthen its generation, storage, and distribution system. The Ministry of Power has already launched several important initiatives, which includes installation of large-scale battery energy storage systems to store renewable energy and manage supply during peak hours. The government is also pushing the National Green Hydrogen Mission, which aims to promote clean hydrogen as a fuel for the industry and energy. In addition, efforts are also being made to modernize the grid through a smart power distribution system, which helps improve efficiency, reduce losses, and ensure better reliability. Another major focus area is the development of electric vehicles charging infrastructure, which is essential as the number of electric vehicles in the country continues to grow. So, with increasing energy demand and the growing use of renewable energy sources, the intelligent systems are becoming extremely important for making power system more efficient, reliable, and sustainable. In power generation, the intelligence and machine learning are helping optimize plant operations, forecast electricity demand, and predict equipment failure in advance. Intelligent monitoring system can analyze real-time data from turbine, generators, and boilers to improve efficiency and reduce downtime. In power transmission, the intelligent systems helps monitor and manage large transmission network more effectively. Smart sensors and automated systems can quickly detect faults, control power flow, and prevent large scale failure. Advanced algorithms are also being developed, especially when renewable energy sources like solar and wind introduce variability. When we look at a power distribution, the intelligent system from the core of the smart grid use digital communications, automation, and real-time data to balance electricity supply and demand. Technologies like IoT devices and smart meters helps utilizes, monitors energy usage, reduce losses, and restore power quickly during the outages. Intelligent system also supports the integration of renewable energy, energy storage, and electric vehicles, making the power grid more flexible and resilient. At the same time, they empower consumers by giving them real-time information about their energy consumptions, encouraging more efficient use of electricity. In simple terms, the intelligent systems are transforming the traditional into a smarter, more responsive, and more sustainable infrastructure. As engineers and researchers, it is our responsibility to use these technologies wisely to ensure reliable and affordable energy for future generations. The program like this, which is organized by the CET in combination with the Institution of Engineers, are very valuable because they provide a platform for the sharing ideas, encouraging collaborations, and inspiring young researchers and students. I am confident that the discussions and research presented here will contribute significantly to solving real world engineering challenges. Before I conclude, I once again congratulate the organizers, the speakers, resource persons, and all their
ঢুকেছেন ঢুকেছেন
participants for bringing together experts
না
and
এখনই
young
ঢুকে যান
minds
এরপরই আপনার
on
আছে
which a significant theme.
এরপরই
I
আপনার
wish the program great success and
All of you,
hope
please
that the
mute.
deliberations here will lead to meaningfully contributions to the advancement of intelligent technologies in the core engineering applications. I wish all the participants a very productive and insightful event. Thank you. Thank you very much.
Thank you, sir, for such an inspiring session. We are indebted to you for allotting us a slot today in spite of your busy schedule. Our faculties and students are highly enriched, and we look forward to have you again and again as our chief guest or keynote speakers in our upcoming STDPs. Thank you once again on behalf of the organizing committee and BCET. Thank you, sir.
Thank you. Thank you.
Now, moving forward with our STTP, we will like to have our keynote speaker, Professor Nirmal Kumar Roy. The STTP is a golden chance for all of us to enrich ourselves. Professor Nirmal Kumar Roy is a professor at the Department of Electrical Engineering, NIT Durgapur. He completed his PhD in electrical engineering from the University of South Australia in 2000. His thesis was titled Simulation of Magnetic Field in Human Environment. His research interests include high voltage engineering and IoT and ICT enabled HV application and facilities, online monitoring with laser and optical technique, magnetic fields near power lines and human environment for possible biological effect, renewable energy systems, energy management, e-education, e-learning, and e-governance. He has published papers in 89 reputed national and international journals. We feel proud to announce that he had received the National Overseas Scholarship in the year 1993 under Ministry of Human Resources and Development, Government of India. And not only that, he had even been recognized as the Technology Angel in the year 2007 by the Department of Science and Technology, Government of India. We are really indebted to you, sir, for having among us today in spite of being so busy academically. I would now request Professor Roy to address the virtual gathering without wasting any time. Thank you, sir. I hand over the session to you.
Thanks. So, without wasting any time, first of all, I want to thank the organizer of that IEEE Institute of Engineers and Bengal Engineering College of Technology. So, this faculty development program basically related with the recent topic, that recent advancement in intelligent systems as well as smart technologies for core engineering application, that is very much required. So I will try to highlight on the specific points that basically will highlight the main objectives, how we can use the technology for mankind, and especially that energy is nowadays a great emphasis all over world. So I will talk about that renewable energy as the solar energy. So without wasting time, just I'll switch over to my presentation. So this mapping over the presentation
I will first discuss the challenge number one. What is the challenge number one? That is knowledge economy. And second is the challenge number two, that is technological innovation where energy is prime. And we'll also discuss here that what is the disparity in that world energy distribution and what are the policies for the World Energy Council. And I will highlight especially the renewable energy as the solar energy, and this is the key to fulfill the energy security. So it is also the prime mover of the renewable energy, that solar energy. And recently that we have installed 1.1 megawatt solar plant in at NIT Durgapur. So I will discuss about that this solar rooftop PV system, where it will be covering that off-grid, on-grid, and hybrid solar system, as well as the different topologies for solar energy. And we'll also discuss about what are the opportunities and top 5 solar energy power plant in India, as well as that I will give little bit the details of that 1.07 megawatt rooftop solar power plant at NIT Durgapur. So what is that knowledge economy? That knowledge economy, when you highlight, then in 20th century to the 21st century, that you'll see that product to ideas, that is the main emphasis, that there is no more that products are very important. Now ideas are very important. And it has switched over to manufacturing to services. Now again, that services are very important. Then it comes to that public policy to the markets, and there is no that public policy more that the importance is getting nowadays, that markets, it is depending on the market basically. And you can also that give the example that say that in geo, that geo, when it geo came, that government policy, they have bound to do that, okay, depending on the market, that geo they have decided their market basically. So that's why the public policy is no more than very important now. That is, now the markets is very important. And that last one, that is monopoly to the innovation. And nowadays that monopoly is also not very much that useful, because you see that in earlier days that say Bajaj scooter, if you want to buy a Bajaj scooter, you have to wait for say 4 years, 5 years like that. But now that what happened, that there is no monopoly. Now if you have money, you go to that shop and you can buy that anything, any scooter, any car, anything you can buy. This is the change has happened in 21st century. And this, we are also creating that intangible assets, which is basically that skilled workers to that patents it is going, and know-how, and it is ballooning from 20% to that 70%, because now that every single year that knowledge is basically increasing. Okay, and we are entering a new age, that is age of knowledge, that you can't deny. So even that in Microsoft, that Bill Gates has told, say 15 years back, he's told the society is now converting to the knowledge-based society. But now it has changed again. Not knowledge is also not everything. Now that say Jack Ma, that AliExpress, okay, that Ali, okay, that shopping online, soft banks, okay, that Jack Ma, he has told that knowledge is not more. You need that innovation. So now that knowledge basically is coming to that in innovation, then only it will be useful. And that's why we are telling that connect knowledge into wisdom should be the aim for every individual. So if you see in this slide that DIKW triangle for today's key to achieve the success. Here, the growth of knowledge, if you compare in 1956, it was X. It has doubled in 1976. Then it took 20 years, but after 10 years, that 1986, that it was 4x, then 8x, like that it is increasing. In today's scenario, if you see that every 2 months, the knowledge is getting doubled. Every 2 months, the knowledge is getting doubled, and growth of knowledge is happening with very rapid speed. And here you can see that one DIKW triangle. In that DIKW triangle for any intelligent system or any industry, that is very important, that this is DIKW triangle. That first in base, that is data, and second is that information, from data to that information it overs, and from information to the knowledge it goes to that peak of the triangle. Then after that, this peak, that knowledge is not sufficient. So data, information and knowledge is not sufficient. You need that wisdom, because built on data, guided by knowledge and defined by wisdom, any that system, if you compare, say for any industry, if you have you have to collect the data, then you have to use the sensors. If you want to process that and create that information, then you have to use that processors. Then after that, if you have to build up something, then you have to use that knowledge there. And after using that knowledge, you can create that wisdom. That's why that built on data, guided by that knowledge and defined by wisdom. This is the DIKW triangle, and this is very much important for DIK triangle. It represents the accumulated knowledge and strategic relationships and creative innovations that make an entity more valuable than just its physical assets, called intangible assets. So you have to create that intangible assets, and you have to create some products. That's why one thing in this program, it has clearly defined that that applications are everything. That if you don't have that application, then it is a closed library. If you have knowledge, then only that you can use that knowledge in closed library. But if you want to build something, like some products like that, then it is the application. So you have to convert this in application, and that wisdom is very much important for that. So the second part, that key challenge number 2, that is technological innovation, is the today's key challenge number 2. Here we have seen the change from 20th century to 21st century, that is commodities to innovation. Now that commodities are not very important, okay, now that innovation is very much important. And here another thing also, second part, we have seen that analysis to synthesis. Anything that if you analyze, that is also not sufficient. You have to basically understand that things, and you have to implement in that way. And reductionism to that conscience. That reduction means you don't have to go for each and every part, molecular basis or molecule basis or in atom basis, you don't have to go. You have to basically make that knowledge to the discipline merges, and it will be unified and holistic understanding of reality. Then only that reaction to the conscience will be there. And last part, that is hierarchy to networks. And this is very important, that hierarchy to networks means that earlier days we have that, okay, that lower level, that hierarchy, if you see, that it is going to the director, like that. So there are faculty members and staffs, and there will be some middle level, that officers, then it will be the director is there. That hierarchical is not that nowadays is very relevant now. Now that this networking is very much important. So that hierarchy to the networking, that is the technological innovation will be happening, say, with this way. Now that if you compare that this 1780s to that in today's era, now that steam powers, it came 1780s to that one technology that came 1780s to 1840s, and 1980s to that it is going on, that IT, information technology. Then in 2010s that Bionet came. Then after that, after 2014, we have seen that industrial automation, then smart health, then smart home, smart city. Now we are thinking about that living on Mars. But with this all that technology that is growing with that different sectors, where that energy is very important. So now that the in recent technology, you see that everywhere that AI or data centers, if you compare data centers, for data centers, that energy is very much important. Energy will be the prime mover of anything now. So this energy we have to say, and especially for that renewable energy. So if you see that the disparity that, say, population around 60% at Asia Pacific, share of energy only 48%. Rather, that if you see North America, that 5% population, they are consuming around 16% share of energy. So this is the disparity is happening. That's why you see that they are very much comfortable position. If you see that 1.2 billion people are in very comfortable position, but if you see here that 6 billion people are traveling like that. Okay, so this is the scenario, that is the disparity of that world energy distribution that we have to basically address. That how we can address this is possible only that this renewable energy. So that's why that policies for that World Energy Council that has given that this one is that energy triangle, another is energy market. So what is that energy triangle? Energy triangle is that it's a triangle of that energy equity. That means depends on the social strength, that everybody should get that energy, and environmental sustainability, that is depends on that economical strength. If you don't have money, then you can't think about that environment. Okay, so that is depends on the economical strength. And energy security, that is depending upon the political strength, basically depends on political strength. That has given that energy triangle, and they have also given one energy market. That is also very important, that it is having in three scenarios. That is, one is that modern jazz, another is unfinished symphony, and third is that hard rock. What is that? This modern jazz will be innovative. That means we will be implementing everything in a smart that electricity card. If you don't have money, you can't consume that electricity. That is modern. This is too much that hard for that in poor people. But you have to, if you want to drive your economy well, then you have to be innovative, digitally disruptive, and it is consumer market driven basically. But unfinished sequence, this is the in between, that you don't have to take that all this also that voter-led scenario. That means the poor people also can get the access, and that's why it is called unfinished symphony. And third is that hard rock that explores that weaker and unsustainable economy. That is very much that crucial thing. That means it's in Africa or some places. That is hard rock basically. That's why. And one more thing also, that carbon emission is also important issue for policy formulation by WEC, World Energy Council. And you see that energy security, how basically it is governing. So first thing is that in energy conservation, and second is that energy efficiency. This will go that energy efficiency. Last is that in renewable energy. So first of all, you have to follow this energy conservation. If you have that sufficient energy, then you don't have to think about the conservation. But all the developed countries, they are given the priority that energy conservation and energy efficiency also. But unfortunately, that in India, that we are not giving much emphasis on that energy conservation and energy efficiency. Okay, there are few companies are there, they are only trying, but this energy efficiency is very important. And third is that if you can't basically make up your energy with this two system, energy conservation and energy efficiency, then you have to go for that in renewable energy. And that will give you that energy security. So that's why the renewable energy is the key to fulfill the energy security, and that will give basically secured and clean power for all by 2030. And what is solar energy? So I'm telling that is solar. Why I'm talking about solar energy? Because in India we are having that highest that this renewable energy as solar energy, and it is basically giving in two ways that energy can be given. That one is in thermal route, another is in that electrical route. And thermal route, we know that okay, we can produce that hot water and air and cook food, drying materials like that with that in thermal route. And if you go for that in electrical route, then we can generate electricity for lighting home and building and running motors. That all everybody know. And this is the map, solar map at night, basically in India. And if you have that sufficient renewable energy, then we don't have to think. And India is basically going in that direction, and we are producing a lot of that solar energy. So if you see that the growth of solar power with others, then if that LinkedIn is that 94% pace it is growing, but solar power is growing almost that 40% growth. So this is worldwide. This is worldwide scenario, and in India also we are doing very good. And India's solar energy landscape, if you see that we are having for until that in March 2026 around 140.60 gigawatt. That means 140,000 megawatt we are basically generating now. Okay, we have the installed capacity. This is not generation. This is the installed capacity, and we have the target that in 2030 that will be going for the 500 gigawatt. And here that Rajasthan and Gujarat are the leaders basically for that. And we are having that the system for that rooftop and grid integration. Another as that this the regional leaders, if you see that this Rajasthan and Gujarat, and presently that we are having around 140,000 megawatt that's installed capacity of solar. That's why we are telling that this is the prime mover of that renewable energy. And you see that the solar rooftop PV system. What is that? That's basically that in every house that you'll be seeing, say after 10 years, I think that every house there are so many that so many government schemes are coming. That is, one is that Surya Ghar, that PM Surya Ghar, one is there in central government, and in state government they are giving the Rajasri. Okay, that is solar rooftop PV system. What is there? That is the three different type PV cells are there: single crystal PV cells, and then polycrystalline cells and amorphous cells. And this will be in that your rooftop, and it will be giving the 2 kilowatt. If you are having 3 kilowatt, that total that meter capacity, that will be for 3 kilowatt you'll be getting that in solar power. Okay, and if you have 5 kilowatt, you can install that 5 kilowatt solar power, rooftop solar power. And this is basically DC voltage, and we are converting the DC voltage with the inverter. So PV cells, if you see how basically given that this is a single cell, then it creates with multiple cells series, and that parallel it is creating one that module, and after that module is creating one array. That way it builds up. And the solar energy, if you see that solar insolation constant, especially that per square meter how much energy you will be getting. So the per square meter around that 1053 watt per meter square. So you can easily calculate that how much that area is required for your 3 kilowatt that solar power plant at your rooftop. And this is the characteristics of PV cell. Basically we are getting that maximum power point here with that voltage to that current. If VI characteristic you see, that is the short circuit current, and that is the open circuit voltage, and that is you can get that that 20 volt, or single one it is getting 0.6 volt like that for photovoltaic cell. Okay, so what is that off grid? This we should emphasize basically. What is that off grid power PV power system? This off grid PV power system basically that you should be having that battery or storage, any type of battery or any type of storage will be there, and it is suitable for that grid power where it is not available, and where the frequent power cuts are there. Okay, that is suitable for that offline. But the disadvantage here that this power management is complex due to excess power if battery power is not used every day, and the extra power will be wasted, which is allotted for battery charging. And it needs also extra cost for electricity from grid for charging of battery. Okay, this is the disadvantage basically. And it is also that more capital cost is required. Say if you want to install 1 kilowatt on grid power system, that will be around say 40 to 50,000. But if you want off grid 1 kilowatt, that will be around 80 to 90,000. So that is the difference for off grid PV power system. And grid connected PV power system, that is on grid, that the thing is that where the suitable that 24/7 power supply is available and minimum power cut. Okay, and here less capital cost that I have told, and no wastage of electricity. Now that there are different that metering system that we'll discuss later on. And the disadvantage, no power will be available when there will be no grid power. That is the on-grid power system. This is the disadvantage. When that grid will be not there, then you will be not getting the power in on-grid power system. And hybrid PV power system, that is there are three types. That the thing, one is that I have told that off-grid, another is on-grid, and third one is the hybrid PV power system. That is more capital cost again because it involves the battery, and it also that will be giving that extra power grid through solar grid hybrid type inverter and net kilowatt hour meter. and power will be available 24 by. This is the advantage, that power will be available for 24 by 7. If that solar power is not available, if the grid power is available, you can consume the grid power. And different topologies, if you see here, one topology I'll be describing here, that you see that if you have solar availability 1000 watt solar availability, then that if you don't have any demand in your home, then total that electricity will be given to the grid in case one. Okay, that means this power will be going to that in this inverter through controller, and it will be going to that in grid. So that way, that that first case one, that is one topology. And second topology is that if you are having 1000 watt solar availability, but you need that 400 watt, then you can give 600 watt to that in grid. So this is another that case. And case 3, you can see that if you are having that this for 600 kilowatt only, but you need that 1000 watt load, then you will be just taking the power from the grid 400 watt. So this is the different topologies we follow basically for the on-grid power system. And what are the opportunities and top 5 solar energy power plant in India? So opportunities mean, if you see that the solar installation constant and that total per day, that how much unit you'll be getting from different region of that in India. You see here that in Gujarat and Rajasthan are very much popular, because here you can get the 6 units per day, 6 units per day from that solar energy, 6 units. If you have 1 square meter, that area, that is 6 units per day, that you can get the solar energy here. But if you come to that in that our part in Kolkata and that part, around 5.4. But if you take that efficiency, it will be around say 3 to 4 units per day you will be getting per square meter or per kilowatt installation. Okay, so that's the scenario. And the first, that Rajasthan Bhadla solar park, that is 2245 megawatt, that installation first, that is the biggest one in India. And we are also having in different region that this is in Karnataka, that we are getting around 2050 megawatt power plant, solar power plant. Then next we are coming to that we have installed one that 1.07 megawatt rooftop solar power plant at NIT Durgapur. And we have got this one through that power grid PSU unit, and they have basically given with that their CSR fund, corporate social responsibility fund, and this is a free of cost NIT Durgapur has got. And they have given around 5.95 crores, and we can basically generate approximately that 15,596 megawatt hour of energy that, and we can save around 1.18 crore per year. And we are getting also that, I'll be showing that. So I'll discuss first that, okay, what are the steps we have taken for that. So first we have taken that physical survey of each site. So we have done that physical survey. Then that feasible that rooftop area we have chosen. Then after that we have designed that feasible social power, the solar power plant's capacity we have considered, and PV module we have considered. Then that through that engineering software, AutoCAD and PV system, and we have designed everything, and we have verified the design. Then after that we have executed that project. So these are the survey of sites. We can see this is survey of sites and Google Earth view. Then this is the feasible that rooftop area that we have chosen. This is the feasible rooftop area. You can see here what is the feasible rooftop area. So there will be no shade area, so you can get very good electricity in that region. So that way we have made that this feasible rooftop area. Then we have designed also this total, that how many that slabs will be there, and how many structures will be there, that we have designed here, and what will be the size of the panel, that also designed here. And these are the design part of that. And PV panel and solar inverter used 520 to 550 watts, that panel we have used, and that inverter, Thea Touch inverter we have used in our basically this work, that Thea Touch inverter. That's a very good, this online you can basically monitor that what are the plants are now working, what are the plants are not working, that we can monitor through this inverter software. They have given the software, and it is app based, and you can basically operate anywhere in the world. Anywhere you go, you see that what are the generation is happening. Okay, this is the app they have given, and we have basically 23 sites. Okay, 23 buildings we have considered, and each building is having, and this is yesterday's data, 9th March data, that we have got around, say this is around, I think 3:30 or 4:30, we have recorded that around 2709 units we have got, and this total that hours we have just calculated how many hours we have taken, that 27th of this will be the display. And yesterday there is a cloud, so that you can see that this peak and summer we have got. So this is for one system. This is for our electrical building, I think this one. So this is the this power plot for this, how much power we have got whole day yesterday's, and the generation report 9 months and this whole year. So if you see here that we have got in January around 89,000. Okay, 89,000. That I'll show that report. And February it is more little bit, in almost that 196,000 we have got, and this is the tree planting. Okay, this is whatever the carbon dioxide we have saved. Okay, so this is 143 tons carbon dioxide we have saved. That is also recorded every day. That is recorded 143.6 metric ton that carbon dioxide we have saved till date. This is only that started from January. So the January, February, that 143 metric ton that carbon dioxide we have saved, and that is equivalent to that tree planting of 402 tree plantation. Okay, so that is equivalent to 402 tree plantation. And yesterday that basically we have got around 2,700 2.71 megawatt hour. Okay, 2710 that kilowatt hour, that unit we have got, and this is basically for this January data, and this one is the February data, and this is March. Okay. Now this generation report that I have told, that in February this report, generation report, the January, that total unit we have got. Okay, for full January, that is every day's the generation report we have. And what is that concept of net metering? Basically, we have not installed the net metering, but you should know about that net metering, net billing, and gross metering. Net metering means that it will be bidirectional, and you will be getting whatever that energy you consume, and whatever energy you will be selling to that in grid. So that will be all that equivalent to that in the tariff of that West Bengal State Electricity Board or that CSC, Calcutta Electric Supply. But net billing, it will be a little bit different. Net billing is basically that whatever you will be selling, that will be not in the same rate what that you are paying. Basically, that is a different rate. That rate will be decided by that electricity company. But gross metering is if you install a big solar power plant, you can sell that with the auction. Basically, how much that the every days that solar tariff will be there, you can access. So there are three things. One is that net metering, other is net billing, other is gross metering. So net metering is very beneficial. So we are trying about this net metering. I don't know that, okay, this will be happening or not, because we are taking the connection from DVC. So DVC, if they will agree, then we can go for that, this net metering. And next is that net billing is not very much, okay, that profitable. But for industry that who wants to basically generate that electricity in industrial concept, then they can sell with that gross metering concept. Okay, and if you see that financial analysis and payback period for solar power plant in Durgapur, it will take around 7.33 years. Okay, that we have seen that whatever that, although that we have not paid the money, but the Power Grid Corporation, they have paid the money. So that will be around, say, 7.33 years it will be taking for payback period. So that also we have calculated a payback period. So overall, you see that it is very much beneficial for solar rooftop power plant. So I will advise everybody, or I will suggest everybody, not advise, I will suggest everybody that, okay, that you go for that in different scheme. That is, one is that in Sriaghar, and there is, I think, West Bengal government, they are giving Alasri that scheme. and they are giving basically 8,000. They are giving full subsidy for the net metering. Okay, and you'll be only that they'll be giving a subsidy of for I think for 3 kilowatt it will be around 78,000 like that. Okay, that you can incur. Okay, so I think that we have covered that in solar energy. Now this the conclusion is that nowadays with this recent technological advancements, you have to invent, then insist, then implement, and after that you have to conceive, consult, and collaborate. Okay, these three I's and three C's are very important. So I hope that everybody will be agreeing with these three I's and three C's. Okay, thank you very much. You all grow with challenges and get success with hard work. Okay, thank you very much. I have a class now. Okay, from 11 o'clock. Thank you very much. Thank you.
Thank you, sir, for such a knowledgeable session. Your way of explanation and use of such effective slides greatly enriched us. With an earnest request of having similar offline sessions with you in future, we once again thank you wholeheartedly for sharing your precious time with our institution. Thank you, sir.
Okay,
Now,
sorry for that. I'm not able to take questions now because that's already 11 o'clock. Okay.
it's okay, sir, not an issue.
Okay.
Now I would like to hand over the session once again to Mintu Ghosh sir so that we can continue with the STTP as usual.
Thank you very much, ma'am. Now I admire the motivation provided by our respected principal, sir, Dr. Santanu Kole, to organize this event. And now I request our principal, sir, and also the patron of this program, Dr. Kole, to kindly address and welcome the online gathering. So, principal, sir, please, it is over to you.
Good morning to all respected dignitaries, distinguished speakers, faculty members, researchers, and dear participants. It is a great pleasure and honor to welcome you to the 5-day online short-term course faculty development program on recent advances in intelligent systems and smart technologies for core engineering applications, scheduled from 10th March to 14th March 2026. This program is jointly organized by Department of Core Engineering, Electronics and Communication Engineering, Mechanical, Electrical, Civil Engineering, along with departments of Basic Sciences, including Chemistry, Physics, Mathematics, and English, in collaboration with the esteemed the Institution of Engineers, India, in the Durgapur local center. At the outset, I extend my heartfelt gratitude to all the resource persons, experts, and academicians who have kindly agreed to share their knowledge and expertise in this program. Your presence will undoubtedly enrich the leading experience of all participants. In the present era, intelligent systems and smart technologies are transforming the landscape of engineering and scientific research. From smart infrastructure and intelligent manufacturing to advanced communication networks and energy systems, these technologies are reshaping how we design, analyze, and implement engineering solutions. Therefore, it has become essential for academicians, researchers, and professionals to stay updated with the latest developments in these interdisciplinary domains. The FDP has been thoughtfully designed to create knowledge-sharing platform where experts from academia and industry will discuss emerging trends such as artificial intelligence, machine learning, smart sensing systems, intelligent control, advanced material, smart infrastructure applications in core engineering fields. The objective of this program is not only to enhance technical knowledge, but also to encourage collaboration, research innovation, and interdisciplinary thinking among participants. I strongly believe that over the next 5 days, this program will provide valuable insights, simulate intellectual discussions, and open avenues for research and development in intelligent and smart engineering technologies. I would also like to sincerely thank to the organizing committee, coordinators, faculty members, and collaborators from the Institution of Engineers India Durgapur Local Center for their continuous support and effort in making this program possible. To all the participants, I encourage you to actively engage in this session, interact with experts, and make the best use of the learning opportunity. With these words, I once again warmly welcome you and wish 5-day FDP on recent advances in intelligent systems and smart technologies for core engineering applications great success. Thank you to all. Have a wonderful, productive program ahead. Jai Hind.
Thank you very much, sir, for your such encouraging words. Now I acknowledge the continuous support of the Honorary Secretary of the Institute of Engineers, Dr. Arup Kumar Mandal, in all the way of organizing this event. And I request Dr. Mandal to propose the vote of thanks of this introductory session. So please, it is over to you.
Thank you. I think I am audible to all.
Yes, yes, sir, you are audible.
Yes. So, as a secretary of Durgapur Local Center, my responsibility to deliver the formal vote of thanks. Respected chief patrons, distinguished chief guest, eminent keynote speaker, chairman of the sessions, directors and principal of the institution, esteemed faculty members, participants, good morning to all of you. It is my privilege and pleasant duty to propose the vote of thanks at the conclusion of this inaugural session of the 5 days short-term training program on the recent advances in intelligent system and smart technologies for core engineering applications. At the outset, I express our sincere gratitude to our chief patron, Sri Utkarsh Gautam, sir, Vice Chairman of SKSGI, for his inspiring presence, encouragements, and constant support for academic and professional development activities. I extend our heartfelt thanks to our esteemed chief guest, Sri S.K. Srivastava, sir, former Principal Director of the National Power Training Institute under the Ministry of Power, Government of India, for sharing his valuable insights and motivating words with all of us today. I would also like to express our deep appreciation to our distinguished keynote speaker, Professor Nirmal Kumar Roy of National Institute of Technology, Durgapur, for delivering such enlightening keynote address and also for giving that time in his busy schedule. I think within 3 to 4 days notice, we can get his lecture or get his presence to deliver the lecture. My sincere thanks also goes to Professor A.C. Ganguly sir, Director, Admin, SKSGI, and Professor S. Kole, Principal of Bengal College of Engineering and Technology, for their encouragement and continuous support in organizing this program. I would also like to acknowledge the dedicated efforts of the conveners, coordinators, and members of the organizing and advisory committee, whose hard work and meticulous planning made this program possible. And I also thank the main things of this program, like the resource persons, because without their support, this program could not be possible to make this safe. So I also thank a resource person who will deliver their lectures in these 5 days, including Dr. Arya Jyoti Goswami from NIT Durgapur, Dr. Deeptesh Das from NIT Durgapur, Dr. Rovikant Jain from CSR CMERI, Dr. Tushar Kanti Bera from NIT Durgapur, Dr. S. Banerjee from NIT Durgapur, Dr. Vivekanand Sharma from IMPS Paris, Dr. Hemanta Mandal from NIT Durgapur, Dr. Sudhir Kumar from IIT Patna, Dr. Subhash Chandra Saha, School of Mechanical and Mechatronics Engineering, Australia, and Dr. Pradeep Kumar Roy from IIT BHU, Varanasi. I express my sincere appreciation to all participants who have joined this program. With these words, I once again thank everyone for their presence and contribution and wish the program a great success. Thank you all.
Thank you very much, sir, for your brief of this session. And by this, we have come to the end of the inaugural session. Thank you once again. Thank you all. So without wasting our time, within 1 minute, we are going to start the much awaited first technical session on intelligent systems and smart technologies in mechanical engineering by Dr. Arjajyoti Goswami from NIT Durgapur. So please wait for 1 minute. Just after changing the recording part, we will start the session.